Dear children, today we'll discuss about reflection. This chapter you have learned in class 10. Here in details we will learn. Then what is reflection? Reflection, you remember, it is a phenomenon in which a ray of light returns back into the same medium after striking a surface. So here you see it is incident light, it is the reflecting surface. When it incidents on it, the light is reflected back or returns back into the same medium. So this phenomenon is called as reflection. So now, what are the laws of reflection? Laws of reflection. You see, the ray coming towards the reflecting surface is called as incident ray. The ray returns back from the surface is called as reflected ray, and it is the normal. There are two laws. The first law is that the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. And number two, you see the angle made by incident ray with the normal is called as angle of incidence. The angle made by reflected ray with normal is called as angle of reflection. So now the angle of incidence is equal to angle of reflection. I is equal to R. So here you learnt the laws of reflection. So now come to mirror. What is mirror? Mirror is a good reflecting surface. Mirror, you remember, it is a good reflecting surface. What is plane mirror? Now plane mirror, if the reflecting surface is plane, then it is called as plane mirror. Means flat mirror is called as plane mirror. The representation of the plane mirror is like this. This side is reflecting and this side is silvered. The mirror which we are using at our home, that is the plane mirror. So now we learn image formed by a plane mirror. You take a point object O. This A dash is the plane mirror. Now OA is the incident ray. It is OA incidents normally to the plane mirror. As it incidents normally, angle of incidence is 0. And you know from laws of reflection, angle of incidence is equal to angle of reflection. So the angle of reflection must be 0. So this ray retraces, or the reflected ray retraces the path. Means the reflected ray goes along AO, along the same path. Another ray OB, after reflection it goes along this. It is your angle of incidence and it is your angle of reflection. So now you see the two rays AO and BC, they diverge from each other. When they are produced backward, they meet each other at the point I. So now we can say I is the image point of O. Now from the figure, it is I angle of incidence, it is angle of reflection. I is equal to R. These two angles are equal because they are alternate angles, because these two lines are parallel, it is intersecting line, so this angle is equal to this angle. Similarly, these two are parallel lines, it is the intersecting line, this angle is equal to this angle, that is your R. But you know I is equal to R, that's why AOB and AIB are equal. Now, in two triangles OAB and IAB, these two angles are equal, that is AOB is equal to AIB, since I is equal to R. AP is common and this angle is equal to this angle. OAB is equal to IAB. So these two triangles, now you can say they are congruent with each other. Triangle OAB is congruent with triangle IAB. As two triangles are congruent, their corresponding sides are equal. Now you can write OA is equal to IA. That means object distance is equal to image distance. Now what are the nature of the image formed by the plane mirror? Here the image is virtual. So you remember virtual image, when will you get? If the reflected rays produced backward, they do not meet each other after reflection. When they are produced backward to meet each other, then virtual image is formed. If the two reflected rays actually meet each other, then real image is formed. When the image is virtual, then it is erect. When the image is real, then it is inverted. It is erect image. Now it is laterally inverted. Another important point, that is the image is laterally inverted. Means when you look at a plane mirror, your left hand looks like right hand and your right hand looks like left hand. That is laterally inverted. Same size. Object, here the image has the same size as that of object. Then your image distance is equal to object distance. Here one question I can ask: if you fix a plane mirror on this wall, if you are moving parallel to the wall, then what happens? What is the relative velocity? What is your relative velocity with respect to your image? You know, in the same direction, the relative velocity is u minus v, where u is velocity of the one object and v is velocity of the other object. So when you are moving parallel to the wall, or on this wall you have the plane mirror, you remember your velocity will be equal with your image velocity. That means in a plane mirror, if you are moving parallel to the plane mirror with velocity 10 meter per second, that means your image has the velocity 10 meter per second, because object distance is equal to image distance. So here, as the velocities are equal, so it is u minus u, that is 0. So you remember, when you move parallel to the plane mirror, then your relative velocity with respect to your image is 0. Similarly, here on this wall you have the plane mirror, you are moving to the wall perpendicularly. What is your relative velocity with respect to your image? If you are moving with velocity 10 meter per second, then you will find your image is moving with the same speed in the opposite direction. That means here the relative velocity in the opposite direction, that is, you know, it is u plus v. If your velocity is 10 meter per second and your image velocity, you know, in case of plane mirror, that is same as that of u, that is same, that 10 meter per second, 10 plus 10, that is 20 meter per second. So it is your plane mirror. So now come to spherical mirror. What is spherical mirror? It is the mirror which forms a part of a sphere. You see, it is one spherical mirror. You see, you imagine a sphere of which this mirror forms a part. Similarly, it is the plane mirror, it is the mirror, not plane. You see, you can imagine a sphere of which this mirror is a part. So as these mirrors are part of spheres, imaginary spheres, these mirrors are called as spherical mirrors. Now you see this mirror and this mirror. Here you see the reflecting side is convex. Here the reflecting side is concave. You remember, this depressed side is concave and this elevated side is convex. So here it is called as convex mirror and it is concave mirror. It is your convex mirror, and you remember convex mirror is diverging mirror, and it is your concave mirror. You remember concave mirror is converging mirror. What is converging and what is diverging? After reflection, if the reflected rays they can actually meet each other at a point, or if they go towards each other, then it is called as converging. After reflection, if the rays go away from each other, that is called as diverging. So now some terms connected with spherical mirror. Some terms. It is a spherical mirror, that is convex. It is concave. First is your pole. What is pole of a mirror? You remember the middle point is called as pole of the mirror. Now come to center of curvature. center of curvature of the mirror. It is the center of imaginary sphere of which the mirror forms a part. It is the sphere, imaginary sphere. It is the center. Similarly, it is the imaginary sphere. It is the center. The center of imaginary sphere of which the mirror forms a part is called as center of curvature. Now come to radius of curvature. What is radius of curvature? That is the same definition, same type definition. That is the radius of imaginary sphere of which the mirror forms a part. Next is your principal axis. What is principal axis? The line passing through the pole and center of curvature is called as principal axis. Now come to number 5. That is principal focus. So, what is principal focus? For this, we have to draw a ray diagram. It is suppose a spherical mirror. Here you see it is the concave mirror. It is the pole. You see, it is a ray, incident ray, parallel to the principal axis. After reflection, it meet at a point of the principal axis that is called as principal focus. Similarly, in case of convex mirror, an incident ray parallel to the principal axis, after reflection, it appears to diverge from a point on the principal axis that is called as principal focus. Now come to focal length. What is focal length? Pole to focus, that is your focal length. Pole to focus, that is the focal. This distance is your focal length. The distance between pole and focus. Now, focal plane. What is focal plane? The vertical plane passing through the principal focus is called as focal plane, or the plane passing through the principal focus and perpendicular to the principal axis is called as focal plane. What is the importance of focal plane? For this, I will draw a ray diagram. It is a concave mirror. If the rays coming parallel to the principal axis, after reflection, they meet each other on the principal axis. That point is called as principal focus. But here the rays are parallel to each other and also parallel to the principal axis. But you see, in the principal axis, these are the rays parallel to each other but not parallel to the principal axis. They meet each other at a point on the focal plane, and this point perpendicular drawn to the principal axis is the focus. It is understood or not? If two rays parallel to each other and also parallel to the principal axis, after reflection they meet each other at the principal focus. But here the two rays parallel to each other but not parallel to the principal axis, after reflection they meet each other not at the principal focus but at a point on the focal plane. If you draw perpendicular to the principal axis, you will find this point, that foot of the perpendicular is the principal focus. So in the next class we will derive mirror formula.